Yeah, what's up guys? Here with me is a structural drawing and I'll be taking you through how to interpret this structural drawing and how to put it on the ground. So let's go through it together. So for today, let's talk about the interpretation of structural drawing on beam. Let's do beam basically for today. So before you start interpreting any drawing, you should come down and look at the note you have under it. Look at it here, you have first floor beam layout. Of course, this is a building story with several floors. You have the ground floor, the first floor, second floor. You may have more than 4 or 5 floors. You understand? You may even have a 10th floor. So this is the first floor of this particular structure that I'm showing you. And look at this. It is the beam layout. It is a layout. A layout is just to tell you how the beams are connected, how they are arranged. That's just the beam layout. Then if you look more closely, you will see that at the left side of the drawing you have some notes and some dimension at the left of the drawing, but to the right you actually have nothing, but it has been written on it that same as grid 1b to 6 bar / a to b. What this means is that everything you have at the left side of the drawing is actually a mirror image of what you should have at the right. So instead of writing another dimension or some nodes around this side, you can just write at the left side and ignore the right side. So whosoever is interpreting this drawing knows that whatsoever you have here is actually a mirror image of what you have here. Okay, so that's one. So let's start with the interpretation of the drawing. I'll just take out 2 beams and we'll talk about it. With those 2 beams you can actually do anything on the beam. So if you look at this beam, you have first floor beam 7, and that is this beam. This beam from this big column down to this beam, that is beam 7. You understand? From this point down to this point, that's beam 7, and it has 3 columns, 1, 2 and 3. That's beam 7. The dimension is written next to it, which is 300 by 600 millimeters. You are seeing here, this beam is first floor beam 7. You can see it start from here to that last column there. That's the first floor beam 7. You understand? If you look at the drawing here, hold on. If you look at the drawing here, you see you have how many columns? 1, 2 and 3. You can see. So that's the one beam there, the one column over there. This is the second column, and this is the okay, but funny enough, this is just a beam layout. This will just tell you how the beams are connected. It will not tell you the actual detail of the beam. It will not tell you the lapping length of the beam. It will not tell you how long the reinforcement of the beam is. It will not tell you the diameter of the beam. It will not tell you the spacing that should be within the stirrup of the beam. It will just tell you how the beams are arranged. So in order to now get the depth and everything, the diameter of the bar and everything you should use for the beam, you have to go and check the detail of the beam. The detail will surely be attached to the drawing. So this is how to check the detail of a beam. Let's check the detail of this particular beam, this beam. For you to check the detail of the beam, you will come close and say, okay, what is the name of this beam? Look at it here. It is first floor beam 7. Then you now go to the details. Now, this is the detail. This is the page where we have the details of the beam. Look at it. Look at the note under first floor beam details. This is now the details. It is not the beam layout here. This will just tell you the details, how the beams are arranged. This is what you actually need to arrange your beam, to arrange the steel in your beam. I mean the reinforcement, the rebar in your beam. So you're looking for beam 7. If you look at it, this is what first floor beam 7. The dimension is 300 mm by 600 mm. Definitely this is the beam we are looking for. We are not looking for this beam. If you look at this beam, this is first floor beam 9. Definitely we are not looking for this beam. We are actually looking for this beam. We are actually looking for the detail of this beam. So now let's interpret this detail. You see, you have several lines here, and all the line they have a meaning. You see this line you are seeing. Okay, first of all, let me explain this. You see, this is a column. It's telling you that there is a column here. Also, you can see something like that here as well. It's telling that there is a column. Also here, it is telling that there is a column, and the column is coming from the ground floor. Don't forget that the floor we are checking for is the first floor. Definitely there will have been a ground floor under. So this column is coming from the ground floor and is now connecting to this beam. This is the beam. This is the beam. This horizontal element is the beam. All these vertical ones are the column. This vertical one, these three vertical ones, they are the column. You understand? So this portion is telling that okay, there's a beam and there is a column that is coming from the ground floor and entering this beam. Also here there is a column coming from the ground floor entering this beam. Also there is a column coming from ground floor entering this beam. And from this beam there is another column going from this beam to another floor, and that will be second floor. That's why you're having it at the top here. You understand? At times you may have a column at the bottom, but you will not have at the top. But this column is particular one is telling that this column is coming from the ground floor and it's still going to the first floor, to the next floor, which is the second floor. It will not terminate at this floor. The same thing for here. The same thing for here. Let me show you one thing. Unlike this beam, if you look at this beam, this is a column. This is still first floor beam. This is a column that is coming from the ground floor, and the column is still going to the next floor because you can see something upward here. Look at this. This is a column that is going from the first floor and going to the next floor, but the column is not coming from the ground floor. You understand? Look at this. A column is coming from the ground floor and is still going to the second floor. You understand? Because this you are seeing here is talking about the first floor. This beam is the first floor. So for you to see anything above this first floor, it means it is the second floor. For you to see anything below this first floor, it means it is the ground floor. So this is a column going from the first floor to the second floor. Look at this column. It is not coming from the ground floor. It is just starting from the first floor and going to the second floor. Look at this column. It is coming from the ground floor, but it is not going to the next floor because you can see there is nothing at the top. Look at this column as well. It is not coming from the ground floor. It starts from the first floor and going to the second floor. This column is coming from the ground floor and also going to the second floor. You understand? So let's go back to beam 7. So this column, and this column, they are shown on the beam layout. You can see them in the beam layout. Which is this? Yes, these are the three columns. You can see them. This column 1, this column 2, and this column 3. Let's go back to the details. So all the lines you are seeing here, they actually have a meaning. This external line, they are just concrete boundary. It is not a steel. So look at this first line here as well. It is a concrete boundary. It is a concrete. They are telling you that it is a concrete. This second line, that's where the steel start from. So definitely between this first steel and this first line, which is the concrete, there should be a cover. That's why you are seeing a space. That's the cover between this first one and the concrete. So all these external lines, they are what? They are concrete. Look at this line as well. This line as well. This line is not a reinforcement, because if you check down here, if you trace it down here, you will see that it is an external line. And for it to be an external line, it means that it is a what? It is a concrete. But look at it. It goes up, then comes inside the beam. The line is being transferred inside the beam, just to tell you that there is another concrete in the beam. This line particularly is just to tell you that there is another concrete in the beam. And which is this? This is a section of a beam. If you look at this, it is another section of a beam. It is just telling you that there is a section of a beam. So meaning this line is not a reinforcement. It is just telling you that what? There is a concrete around that side. So if you continue tracing that line, see there, you can see it's telling you that there is another section of a beam here. You can see there's another section of a beam here too. So you keep tracing again, you see it's telling you that there's another section of beam here. Keep tracing, then it comes down to this place, which is an external line. Again, tell you that there's a column here. You understand? So it means this particular line is not what? It is not a reinforcement. So now let's talk about the second line. Obviously you know that the second line is the what? Is the reinforcement, and that is what you actually need to arrange your bars. So the first one, which is the reinforcement, it has been dimensioned over here. You can see the line has been picked out and then dimensioned. The dimension on it is what? 4y20 42. That 4 is the number of the bars you need. It's telling you that you need 4 numbers of that particular bar. I don't know the diameter of that bar yet. This Y is telling you the type of steel you are using. That Y means it is a high yield strength steel. Assuming it is R, you have 4R20. It means the steel you are using is a mild steel. But because you're having Y here, it means it is what? High yield strength steel. Now, this 20 that follows it, this 20 is talking about the diameter of the bar you are supposed to use, which is what? 20 mm. So 4Y20 means you should use 4 numbers of 20 mm high yield strength steel. It's this bar, you can see you have how many numbers? 1, 2, 3, 4, and the diameter of the bar is 20 mm. I'm looking at it if I can see where because they usually write it on it. We can see it 20 mm real TMT. That's the manufacturer of the steel. You can see it here 20 mm. So the diameter of this bar is what? 20 mm. Then 42. What is 42 talking about? 42 is a bar mark. Bar mark. This is just to tell you, bar mark is just to tell you about the shape of the bar you are using. Is it a straight bar? Is it a cranked bar? Is it a U bar? Is it a V bar? What kind of shape is it? That is what this bar mark is talking about. And for you to now know the correct shape, you have to go and check the bar bending schedule. The bar bending schedule will be produced by the structural engineer, and it should be attached to the structural drawing. You understand? But we are not going to that for now. If you now look at this, it has also been dimensioned to be what? 4Y20 57 means 4 numbers, 20 mm, 57. That is the shape. You understand? So it is running from where? You can see it has a bob length to the top, a bob length going up. The bar is running like this. You can see it's running like this. Then at this point there is a lapping. You can see at this point there is a lapping. There is a lapping of what? 1400. You can see from the center to this point the lapping is what? 700. From that center to this right point there is what? 700. So if you add it together, it is actually 1400. So you lap the bar from here till here. But again, at the bottom you still have another bar, which is this. That bar is also at the bottom, but it is now at the top of this one at the bottom. You understand? This bar is still at the bottom. You can see it's not at the top, of course. It is at the bottom, but it is now placed on this 4Y20. And that one is actually what? 3Y20. But in order to now separate this 4Y20 from this 3Y20, you put a spacer. And that spacer is what you are seeing as a circular section steel here. It has a circular section, so that is the spacer. So if you look at it, you see at the bottom you have how many? This is 1, 2, 3, 4. You understand? Then on that 4 you now have another 3 on it. This is 1, 2, 3. So you can say at the bottom of this beam you have 7Y20. Then in order to separate this beam this bar from this upper bar, you use a spacer. You can see a spacer. So a spacer will come in between them so that you can bind them together. So that is the detail of the beam. The reason why you are having this kind of situation, you can see you are having 4Y20 at the bottom, and at the top of that 4Y20 you are still having another 3Y20, meaning you are now having 7Y20 at the bottom. What that is just telling you is that at the bottom of this beam you have a high sagging moment, because a high sagging moment is related to the bottom bar, hogging moment is related to the top bar. When you have a lot of bars in the top of a beam, it means there is high hogging moment in that beam. If you have a lot of bars in the bottom of a beam, it means there is high sagging moment. So in this beam, it has been calculated that there are 7Y20 in this beam, but because you cannot just put 7Y20 on that portion of the link, it is what's the dimension of the beam? The dimension is 300 by 600, meaning the width is just 300 mm. So how can you put 7 bars of Y20 in a link of 300 mm, and there will be a space? Obviously there will not be a space. That's why you have to put 4 under, then you now put 3 at the top, then you now separate that 4 and that 3 with a spacer. I mean that 4 number and the 3 number with a spacer. Another thing we have to talk about is the links of the bar. The links is that rectangular stirrup. It is also called a stirrup. Is that rectangular bar which all the beams will be placed inside. You understand? The dimension of the stirrup will be given in your bar bending schedule as well. Now look at this. You can see there's something like a dimension here. It is talking about the link. You understand? It's telling that from this point to this point you have a link, and the link is what? 20y by y10, 8 to 50, meaning you have 21 numbers of a stirrup, of a particular stirrup, 21 number of that stirrup. The diameter of that stirrup is what? 10, y10. You already know what y means. 8 is the bar mark, that is the shape. 8 is the bar mark, that is the shape of the link. Obviously for this drawing it is a rectangular shape, and the 250 is talking about the spacing. You see that you don't have something like that when it comes to beam. For the beam you only have 4y20, 42. They won't tell you about the spacing because it is not necessary. But for this case you have 21, y10, 8, 250. So the spacing is what? 250 millimeters. You can see it is around 240. It is not up to 250, but since it is less than 250 it is still better, because a smaller spacing is quite better than a longer spacing, in as much it is uniform. Because if you have 240 here, I also have 240 here, 240 don't. So if you look at this portion of the beam, you see that from here to here you have a different case. It is still y10, the bar mark is still 8, but the spacing has changed from 250 to what? To 150, and you only have 13 numbers. You understand? Because from here to here you can only provide 13 numbers with that spacing. Okay, let's go back to the beam layout and pick another beam so that we can make an example from another beam. Okay, these are beam layouts. I'm going to pick beam 9. You understand? I'm going to pick beam 9. Why? Because beam 9 is a non-prismatic beam. You can see that the beam 7 that we did here is a prismatic beam because it is 300 by 600 throughout. But beam 9 is a non-prismatic beam. It has 2 sections. One section is 225 by 450. The other section is 300 by 600. So that's why I want to talk about beam 9 as well. And it is the longest non-prismatic beam in this structure. So let's pick beam 9. One more thing you should be considerate of is the axis line. You can see this is 1, this is 2, this is 2b, this is 5, this is 5a, this is 6, and at the top you also have some which is a, a2, a3, a5. I'm very sure you are familiar with axis line. So with your axis line you will know how the drawing, when you go and check the detail, you know how the drawing is placed. Is it placed to the right or to the left? You understand? You know where you are coming from and where you are going to. So let's go and check the detail of beam 9. If you want to check the detail of beam 9, you know this beam has 2 sections. One is 225 by 450, the other is 300 by 600. It means this beam probably it will be coming from this point as 225 by 450. Then at a particular point it will now become 300 by 600. But at what point will it now become 300 by 600? You can't know from the beam layout. You understand? You can never know from the beam layout unless you check the beam details. So let's go and check the beam details and know where the non-prismatic beam will change dimension from 225 by 450 to 300 by 600. Okay, Okay, so this is first floor beam 9. Okay, this is the beam we are looking for. This is the beam you have to check the details for. Don't make a mistake of checking up the detail of beam 7 for beam 9. You should be very careful of that. You know, this is a column coming from the first floor and going to the next floor. The same thing for here, the same thing for here, the same thing for here. You are familiar with that now. So what we just need to talk about here is the change in section. This is one section, section 99. It means when you cut across a section here and you now look into this direction, what will you see? You will see the back of this place, that is from here to here. You will not see up to this point here downward. You actually see from here to here. Then we now go and check the cross section that you have for 99. Let's go and see for 99, because they will usually attach a cross section to the span. You know, this is when you're looking at it from the front. This section is when you're looking at it from the side. You can see this is long. When you're looking at the beam from the side, this is when you're looking at the beam from the front. So that section that they cut through, which is 9 bar to 9 bar, what is the dimension you have there? 225 by 450. You understand? 225 by 450. What that tells me and tells you is that from here, you can see that from here you are having the same section. There's no change in depth. It's until here that you have a change in depth. You can see it comes down. Look at it closely. You see that from here to here you have a particular depth. Then when it gets here, it becomes deeper. So, and a section has been cut through here. For you to look at this side, that is from here to here, the section tells you that it is what? 225 by 450. Then another section is being cut through here for you to now look in this direction. That is 9. Don't look at it. It is 9. It is not 9 by this time around. It is 9. And look at it. This section 99. It is what? 300 by 600. So now for a simple interpretation, it means that what? From here down to here, the section of the beam is what? 225 by 450. Then from here to this point, the section has changed to what? 300 by 600. That is a non-prismatic beam. Okay, this is beam 9 with a cantilever at that point. And you can see here you have the column. This is the full length. Yeah, that is beam 9 on the floor. You understand? This is beam 9 on the floor, on the real floor. At this point, that's where you have a change section. So if you look at the dimension of this T-rock, this T-rock will be longer than this T-rock. Don't get it wrong. This T-rock will not be up to 600 because you have to provide some cover for the concrete, but it will be around 400 and something. So if you check the diameter of this, the length of this, the depth of the T-rock, these are around 380. You understand? And if you now check here, what do you have? This 460. You understand? So this is where you have the change in section. Around here you have a 600 by 300 section of beam, and here you have 225 by 450 section of beam. So from here downwards it's 225 by 450, and from here to that point where you have the cantilever, it is what? 300 by 600. So thank you. Another thing we should talk about right now is the lapping. Look at this. Look at this point. You have a lapping. You can see there is a bar coming from the right, then the bar cranks down and another bar is being placed over it at a length of what? 900 millimeters. It means the length at which they touch each other and bonds to each other is 900 millimeters. You understand? So that is the lapping length. The purpose of lapping is that looking at this bar, there is a stress on this bar and the stress is getting too much. You want to transfer the stress of this bar to another bar. You understand? So the stress in this bar, you really have you want to transfer it to this bar. That's why we lap bar. And then for a proper transfer of that stress from one bar to another bar, the lapping length has to be adequate. So according to design, the lapping length of this one is 900. You can see, so if you look at the lapping length here,
This is almost 1,100. You can see. It's even more than 900. You understand? So that's the lapping length. The length that is provided in the drawing is what 900, but to be on the more silver side, so we provided 1,100 on the site. It shouldn't be lesser. It can be greater.